Hello everyone, welcome back. Today, I'm going to reveal something truly exciting, how I built a powerful AI agent that can perform both web automation testing and API automation testing. So, in this video, I'm going to show you how I built this awesome automation agent using two key platforms, N8N and browser use. Let's start with N8N. This is our main workflow automation platform. It's where all the logic happens, where the nodes connect, and where we control the entire process. Now, the second platform is something really exciting. It's called browser use. This one is like a cloud-based browser that you can literally talk to. You just give it a text prompt like open this website and click that button, and it will actually perform that action directly in a real web browser automatically. It's incredible for running web and API automation tests because you don't have to manually open a browser or write complex scripts. You just tell it what to do in plain language. To connect everything together, we generated an API key in browser base. That API key is super important because it allows N8N to talk to the browser use platform. It's how we authenticate every single API call that runs an action on their cloud system. Before moving to N8N Canvas, let me show you its API documentation. I'm using the V1 legacy APIs, and right here you can see all the API details we'll be working with for our automation. Now, there are three main endpoints we're going to focus on: run task, and get task status. These are the backbone of our automation flow, the ones that actually make the agent come alive. If I click on the run task endpoint, you'll see it gives you all the details, including a handy curl command. This curl is basically your ready to go request format. Here's the cool part. In N8N, copy the curl command from the docs, paste it into an HTTPS request node. That's it. Now let me walk you through how I actually constructed the workflow inside N8N, step by step. It all starts with the chat node. This is where we give our initial prompt or input for the test, basically what we want the agent to do. When we start the flow, it also generates a unique session ID which stays with that test throughout the entire process. That ID helps us track everything that happens during that session. Then comes the most important part, the HTTP node. I have renamed it as run task node. So if I search for it, there it is, the HTTP request node. Now this little guy is super powerful. Basically, it lets you connect to any API out there, even if that application doesn't have a pre-built integration in N8N yet. Think of it like your universal connector. If an app has open APIs, you can use this node to send requests, get data, trigger actions, pretty much anything. This node makes a call to the browser use API's run task endpoint. So this right here is the same endpoint we saw earlier. If I open up the run task section, you'll notice it shows a curl command, and as you can see, it's a post call. You'll also see a placeholder for the token, which is what we'll need to replace with our own API key. Now, the cool part is you don't need to write this from scratch. You just click on that curl button, copy the entire command, and then paste it directly inside your HTTPS node in N8N. Super simple. Um, from there, you can replace your token right there in the command, or if you prefer, you can import the curl into N8N first and then update your token field manually. Either way works fine. After that, it's the same API call from the docs, but with my token and some request tweaks. The main one is task, which takes the input we're providing. That's basically the prompt we want the browser to execute. It's super straightforward. You just drag and drop your chat node input right into it. Done. I've also added a few other parameters to make the automation smoother, like save browser data to keep the session consistent between runs. Use ad block so no annoying pop-ups mess up the test. Use proxy if you need to route through a specific region, and highlight elements which visually shows what's happening in the browser as it runs. And if you're wondering where all these parameters come from, they're right there in the API documentation. The docs list every available field and its possible values, so you can just pick what you need and plug it in. You add as key value pair, or simply you can also add a JSON file. So yeah, that's how the base of the agent works. The chat node takes your instruction, the HTTP node sends it to browser use, and browser use executes it live in the browser, all fully automated. Alright, so let's go back to the canvas and move on to the next node. This one's the get status node. Now after running our task, we obviously need a way to track its progress. That's where this comes in. I've added another HTTPS node, and if you open it, you'll see it's using the same API, but this time we're calling the get task status endpoint. We use this node to check whether the task is still running, completed, or failed. Every time it runs, it sends a request to the API and gets back the current status of the task. You can configure how that output looks, maybe as simple text or in JSON format, depending on what fits your flow best. Now, right after this, I've added an if node. This one is crucial. It controls how the workflow reacts based on that status. If the task is still running, it loops back and keeps checking the status again after a short delay. You can see in the workflow, we have added a loop with some wait. But once it detects that the task is finished, it automatically routes forward to the next step in the workflow, which getting task details and generating the test report using an agent. And this needs to execute it only when the task execution is finished. This setup dynamically self-monitors, progressing only when the task is complete. All right, let me show you the if node configuration. So I've set it to check the previous node's status field, and the condition is status is not equal to running. In plain English, if it's not running, that's a true path. If it is running, that's false. Zooming in, you'll see the true and false branches clearly. If it's running, the flow follows the loop path and keeps checking until it's done. Once it's not running coding, it exits the loop and continues to the next step. To avoid hammering the API, I've added a wait node for 5 seconds. So each loop pauses for 5 seconds before checking again. After the wait, we go into an edit fields node. This is just to filter the response because we only need the task ID, nothing else. And if I open this node, you will see the ID is coming from the run task response. You can see it right there. And we simply pass that same ID back to the get task status node on each iteration. As our get task status nodes needs the task ID to fetch the status. So the flow is send prompt, run task, get status, and iterate till task is not finished. Crystal clear and reliable. So moving on to the next node. Once the task is finished, we want to get the full task details. This uses the get task API endpoint, and as you can see, it's the same endpoint we saw in the docs earlier. When I trigger it, the response comes back with a bunch of useful information. Things like the task ID, the original task input, the live URL where the execution actually happened, the output, the status and timestamps for when it was created and when it finished, among others. Now, the big question is, why did I use a code node here? Well, alright, so if you look here, you'll notice that the task ID needs to be in a UUID format, but for some reason my node wasn't returning it that way. So I added a short, simple piece of JavaScript code that automatically converts the ID into the proper UUID format. It's super easy. You can actually pause the video right here, copy the code, and use it in your own workflow if you face the same issue. And we are providing the same UUID to our get task details node. Now, once that's done, we've got all the details of our task, but we don't need everything. We only care about the output field. So I've filtered the response to keep just that one part. But if you need any other fields, you can add that as well. Now, that output becomes the input for our next node, which is the AI agent node. We clean the browser task output and feed it to the AI for the next step. If you look here, you can see the system prompt for the agent. It will act as a test report generator. Basically, it takes the test results and automatically creates a detailed, well-structured test report. Once that report is generated, it then sends it out using the send report tool. Now, what's that tool? It's a simple email sending utility powered by Gmail. It just takes the generated report and delivers it straight to the recipient's inbox. And For the intelligence behind the report generation, we are using Google Gemini as the LLM here, so all the content and structure of the report is AI generated, clean, and professional. Alright, now let's actually test this flow. We'll start with a web test. I'm going to clear the previous session data, and then we'll give the agent a simple prompt. We'll ask it to navigate to a specific website, search for a t-shirt, and then verify if the faded short sleeve t-shirt is present on the UI. It's a basic UI validation test, but perfect for showing how the flow works end to end. Let's hit it. You can see it's generated a new task, and now it's checking the task status. It'll keep looping through until the task is fully complete. If I open the live session view, you can actually watch the execution happening in real time. See here, it's already navigated to the website, searched for t-shirt, and now it's scanning the page for the faded short sleeve t-shirt. Once it finds it, it automatically marks the task as closed. And look at that, the task just finished, and the system has also generated the test report for us. Let's open that up. Here's the email that just arrived. This is our latest test report. It includes the test ID, the test case name, the environment, and all the key execution steps. It also lists the expected result, the actual result, and the final status of the test. Everything you'd expect from a test report. And the best part, the AI agent handled the whole process from running the test, verifying the result, generating the report, to emailing it completely on its own. So yeah, that's our end-to-end web UI testing agent in action. Smooth, intelligent, and fully automated. Alright, now let's test the API flow. We're hitting this endpoint with a get method, checking that the response status is 200, validating that the expected fields are present, and finally logging the product title and price. I'll copy the prompt, paste it in our workflow chat, and kick it off. Same pattern as before. We run the task, it spawns a new session, and the workflow loops, checking status until the task is finished. If I open the session, you can see the API we called and the raw response coming back. Back on the canvas, it's still validating task status. And we're done. Let's check the inbox. Yep. There's the API test report. It lists the endpoint, confirms the 200 success code, shows the validated fields, plus the product title and price that were extracted. Clean, complete, and auto-generated. How cool is that? We've built an agent that handles web automation and API testing end-to-end. Great. So every session is recorded in the browser use cloud platform. It's a paid tool, but perfect for a POC. New accounts usually get around $10 in free credits to try it out. And if you find it really useful for your use cases, you can go ahead and buy more credits. In the tasks section, all previous runs are saved. So at any point of time, you can re-execute any test or even modify the test case and run it again. There's also analytics, how many tasks ran, how many passed, what's pending, and more. So basically you get a detailed insights of your executions. Let's save the workflow. All right, quick callback to our previous videos. If you remember, we already built an agent that pulls details from Jira, generates test cases, sends them for approval, and once approved, creates those test cases back in Jira, links them to the parent story, and notifies you with all the new test case IDs. Now imagine pairing that with today's test automation agent. The idea is simple. Take the test cases generated by the test generation agent and feed them one by one as prompts into this test automation agent. And then we'll have fully automated AI powered end to end testing. Jira already has great triggers with N8N, like on issue update or on assignment. So, whenever a developer finishes their work and assigns the story to you for testing, that event can automatically trigger the flow. So, the moment a story is assigned for testing, the agents lights up. Test cases get created in Jira. Those cases become the inputs for automation. The tests execute and you get structured reports completely hands-free. That's it for this video. In the next one, I'll show you how to connect the two agents, two separate workflows into a single end-to-end system from test case creation to execution to report delivery. That's everything for this session. Keep that momentum going. Don't let the learning stop here. Keep automating and happy testing. Until we see next time.